In problems 5 through 12, you're supposed to verify that the identity is true, which means you need to somehow make one side look like the other side of the equation. In this case, it's usually better to start with the more complicated side to see if you can get it to simplify into the simpler looking side. And in this case, I think the left-hand side looks more complicated. So we'll go ahead and start by expanding the numerator of the left-hand side. And if we distribute everything in the numerator to get rid of the parentheses, then this is our result. And you can rearrange some of the terms in that numerator to see that there is the Pythagorean identity embedded within that numerator. Sine squared plus cosine squared is equal to 1. And so now we can rewrite the left-hand side like this. For the time being, I can't think of anything else that we can do with the left-hand side. We could go ahead and distribute the division and split that up into two fractions, but I'm going to go ahead and leave it the way that it looks and focus on the right-hand side. And so first I'm going to take the right-hand side and rewrite everything in terms of sine and cosine. And now in order to combine these two terms together, we need them to have common denominators. So that will be my next step. Once we combine the two fractions with the common denominator, we can see that we end up with a result on the right-hand side that is the same as the left-hand side. So we're finished. I'm going to approach problem 6 in a similar way where I start with the more complicated looking side. So first I'm going to work with the left-hand side and rewrite everything in terms of sine and cosine. In the numerator, the two fractions, we've got cosine x in the numerator of one and then cosine x in the denominator of another, and so those two will cancel each other out, leaving us with 1 over sine x on top, and then also 1 over sine x on the bottom. And so anything divided by itself gives us a result of 1, which is the same thing as the right-hand side. With problem 7, it's really hard to tell which side looks more complicated. In this case, I'm going to go ahead and start with the left-hand side because that side's not written in terms of sine and cosine yet, whereas the right-hand side already is. So in my mind, just for that reason, the left-hand side is more complicated. So I'm going to go ahead and start with that side and rewrite everything in terms of sine and cosine. Now I can see that I've got almost all my terms having the same denominator of cosine x. There's just one term that doesn't, and that's the one in front. So my next step will be to get a common denominator so that I can combine the two fractions on the top. Now that I've done that, my fraction in the numerator and fraction in the denominator both have a denominator of cosine x, so we can cancel that out. And it seems that's as far as I can take the left-hand side. So I'm going to go ahead and shift my focus over to the right-hand side. First of all, the numerator on the right-hand side, sine squared x, that can be rewritten as 1 minus cosine squared x. It's that variation of the Pythagorean identity. And the only reason that I thought to do that is because I know that that's the difference of two squares, and if I factor that, one of those factors is going to match what we have in the denominator on the right-hand side. And so I'm going to go ahead and factor that numerator, and now two of those factors will cancel out. Now that I've done that, what I have on the right-hand side matches what I have on the left-hand side, so I am good to go. In problem 8, I wanted to introduce a strategy that we may not have gotten a chance to talk about yet, and that's the fact that embedded within this identity is the tangent of x over 2. That's a double angle situation, and those things have their own formulas, so it might actually be beneficial to start this by isolating the term tangent of x over 2. If we do that, then we can just manipulate the right-hand side and hope that it turns into the formula, the half-angle formula for tangent. So in order to isolate the tangent of x over 2, first we would want to subtract cosecant of x from both sides, and then divide both sides by -1. Now we can focus on manipulating the right-hand side to see if we can get it to turn into one of the half-angle formulas for tangent. So first I'll go ahead and rewrite the right-hand side in terms of sine and cosine. By doing that, I've turned this into two fractions that already have a common denominator, so I can go ahead and add those two fractions together. And if you check your formula list that has all the double angle formulas for tangent, that is one of the formulas for the half angle for tangent. So just by combining those two fractions, we've gotten our final answer.